Good morning, dear students. Hope am I audible? Sorry, there was a network issue. That was the reason for delay. Am I audible? Somebody please respond. Am I audible?
Yes, sir, audible.
Yeah.
Yes,
Thank you.
sir.
Thank you. Quickly, we'll start today's class. Okay. Right. So, think strength 23, 24. It's gaining up. So we'll wait for 1 or 2 minutes. Okay. Since there was a delay from my side, okay, I had to see that 1 or 2 minutes I had to wait. Okay. So hopefully they are also facing the similar problem with respect to networks. Okay. Anyhow, we'll be discussing. So in today's class, we'll talk about routing, basics of routing, why exactly routing is required. So far, in with respect to switches used to transmit the data only within local LANs, 2 or 3 networks. So similar networks. So whenever you connect heterogeneous network, we require a router. Router, connects to heterogeneous networks, these different networks, and it will, transmit the data, forwards the data from one host to another host. So we have seen that in the previous class, how exactly it transmits, how exactly it translates the frame format from one different protocol to another different protocol, and how it manages the entire fragmentation. And also we discussed about internet protocol, how exactly it is working, the various components of internet protocol. And today we had a fantastic quiz. I think the all students attended the quiz. 55 students attended. The top scorers, actually Raghavendra and Jayant. I should congratulate them. And I think apart from them, so there are nearly 15 students who are in the range of 26, and another 6 students in the range of 25. So your efforts, whatever you are putting, it is almost close, but nobody has scored out of 4. I was expecting at least some 10 students to get out of 4. So hopefully next internal, okay, next Thursday, same time, we will conduct 10 questions on module 1 and 20 questions on module 2. Module 1 and 2 notes I have already shared in the link. So kindly start preparing. So the preparation should start. So you should prepare some objective type questions like this, and you have to start analyzing. So, and the link which I have sent has got a very good set of good questions, good number of questions. So kindly go through it and continue reading. And the average score is 21.4. So anybody who has scored less than this, so it is an indication, sign that you should have put in a lot of efforts the upcoming internals, second and third internal. So I think the least one was I think 14 or 15. So apart from that, almost everybody got more than 40%. Everybody passed. More than 50%. Everybody passed. Next time when I conduct the internal, I will issue a certificate. Okay, So today we have just released this one. Next time I'll issue a certificate to your email ID. Okay. So I will process and I'll issue the certificate. We'll see that how exactly it can be done. Okay. So coming on to today's class agenda. So we have routing. So in fact, the previous cases, we had two types of networks we have discussed. One is a virtual circuit network. Another one is what we call the datagram network or packet switching. So packet switching network or datagram network. Packet switching network is also called datagram network. In virtual circuit, the routing is an issue only for connection request packet. So all the subsequent packets follow the same path that is been requested. So first packet, that is requested packet, first packet will certainly, what it will do, it will find the route from source to destination. Whatever the route that it finds, the same route will be followed by all the computers, all the packets, and same route will be followed in the case of virtual circuit. So that will not be a problem. So once if you find the routing address for the first packet, all the packets until the entire message completes. So every packet will follow the same thing. Whereas in the case of datagram networks, which includes various IP internet protocol, so internet working, and it has a routing issue with every packet. That means every packet you have to find the best route. You have to find the best route. You have to find it and you have to transmit. The packet has to be transmitted. Every packet has to be transmitted. So that is in the case of datagram networks, and so the two participating components will be used. In case of a normal network, in case of a homogeneous network, so you are having only switches, and in the case of heterogeneous networks, you have routers. The switches makes the decision by consulting the forwarding table. So switches will take decision. So whether to forward in which port, that will be decided based on the entries that are there in the forwarding table. Whereas in the router makes use of its decision. So router has to transmit the data in different routes. So it will consult its routing table, and based on the routing table, so it will take decision. So definitely, you see, in routing table you have different entries, and it is working with the various protocols, different types of protocols. Whereas the forwarding table has the same type of protocol it is transmitting. And of course, the fundamental problem of routing is to find how router acquires the information that is required for finding the path between the source and destination. So this will be done based on the routing table, and the entries in the routing table is the fundamental problem. How to fill these information in the routing table? So that is the fundamental problem that we have. So that is one important thing that you should understand. And the difference between the forwarding table and the routing table. So the difference between the routing table and the forwarding table, certainly you can think of this. So first one, you can see, while the term forwarding table and routing tables are sometimes used interchangeably. Of course, they are used simultaneously. Sometimes whenever you are using forwarding table, of course Forwarding table may also act like a routing table. So we will make a distinction between this routing table and you know forwarding table. We'll make a decision. So here is one example. You see, this is a routing table. This is actually forwarding table. Whatever you are seeing here at the bottom is a forwarding table. So this forwarding table, what it is doing, so it is having the length of the address. So total length. So it is having the prefix. It is having 18 is the prefix, and total length is 8. So 8 and 18 are taken. So interface number is nothing but port number, and here it is using physical address. MAC address. MAC address is nothing but it is a physical address, and physical address is available on your NIC card, network interface card. Every network interface card is fitted by one physical address. So it is a physical address. Physical address will be 48 bytes. Observe here, physical address will be 48 bytes, and all physical address will be 48 bytes only, and it is includes the port number also. Port number is also called as the interface number. So interface number, that is in the case of what do you call the forwarding table. And the forwarding table is used when a packet is being forwarded, and so must contain enough information to accomplish the forwarding function. This means that a row in the forwarding table contains mapping from network prefix to an outgoing interface, and some MAC information such as Ethernet address of the next hop, etc. So Ethernet address of the next hop. Next hop is nothing but, see, this is actually the address it is containing is the address of where exactly it has to go next. So this entire thing. So Ethernet of address of the next hop. So in what address, what interface I have to forward. So that is what it is containing. So it contains the Ethernet address of the next hop. So that is there. In the case of routing table is totally replaced with your MAC address with IP address. So this IP address. So every node in Mac, sorry, every node in internet is referenced by IP address. So here, instead of in place of interface address and MAC address, you have IP address. And remember, IP address is a 32-bit address. It's a 32-bit address. So IPv4 is a 32-bit address. This is a 48-bit address. So which is a less address, and it covers 2 raised to power 32. So large number of computers can be addressed. So that is one advantage that we have with respect to routing table. Routing table records based on the IP address. It is also called as a configurable software virtual address. So anytime you can change, and it is dynamic in nature. Whereas MAC address is a fixed address. MAC address is a fixed address, and it will be stored based on the 48 bits. So it will be stored on 48 bits. So next one, that is routing table, on other hand, is a table that is built by the routing algorithm as a precursor to build the forwarding table. So before forwarding any packet, what happens the first when the routers come up, boots up, it will find out the routes, all the routes. It will take the information from all its neighboring packets by sending a special packet called hello packet. It sends hello packet to all the links. So it floods all the routing it sends all the hello packets across all the links that it has, and based on that link, it will find out. It will find out, what is the total we have, total configuration we have. So, and that configuration information, so everything will be recorded in the routing table, and it is generally containing mapping from network prefixes to network hops to the next network IP address. So it will hold the IP address rather than holding the what do you call the MAC address. So that is the difference that it makes. And in the examination, normally in the interviews, they ask, what is the difference between routing table and forwarding table? So you can certainly write like this: routing table does like this, forwarding table does like this, etc., etc. Okay, so that's the concept related to it. And of course, so before actually any router constructs a routing table, first it considers the entire network as a graph. So I think in graph theory, you might have studied in your BCA, or in your DMS, you might have studied graph theory. So uh, that is the thing. Routing is an essential, problem of graph theory. So normally, based on graph theory only, the routing is actually calculated. Figure 3.2, whatever you are having, shows a graph representing the network, and of course the nodes of the graph labeled A and F may be the host in the sense the computers, or they may be a switches, there may be routers, or any particular component in the network. Okay, and for initial discussion, we will discuss on the case where the nodes are routers. Just imagine all these are routers. So edges of the graph corresponds to network or links. So all A, B, C, D, E, F, all are routers, and you have the edges. So edges are having some values. So these edges we call it as links, and each edges is associated with the cost, which gives some indication of desirability of sending the traffic over the link. So cost is nothing but the expense that incur for transmitting the data from one link to another link, one node to another node. So that is the thing. The basic problem of routing is to find the lowest cost path. So very, very, very important. What is the main purpose? The basic purpose of routing is to find the low cost path between two nodes. So before actually decides which is the route, best route, so it has to find the cheapest route, lowest route, where the cost of path equals the sum of costs of all the edges that make up the path. For a simple network like this one, you can imagine, just calculate all the shortest paths. We assume that edge cost in the network are certainly known. So if you just calculate A to B, so what is the shortest cost? If you do like this, I think you have to apply the algorithm. So shortest path algorithm. So if you take this, you have to spend 3. If you take A, E, and B, so there is 2. So certainly this direct link will not be used. So it will, whenever it wants to transmit to B, it will transmit to E, and from E to B, because cost is less. Similarly, A to F is 6. If you transmit A, E, and F, so it is only 3. So it is just like that. D. So if you go through this path, it is more. If you go to A, E, D, so its cost is less. So like that, some paths are having high cost, some paths are having very less cost. So that will be decided based on you know the cost. So where the cost, you know, the calculation of this cost from one computer to another computer is the process that we have in the case of routing. So calculating the path and what are all the other alternate paths that you are having, and finding out the best path is what routing is doing. So when it comes to different types of routing, there are many types. For your syllabus, you have distance vector routing and link status routing. Actually, we have already written distance vector routing program in the last class itself. So last lab program we have already understood. So protocol is equal to dv, we have written distance vector routing protocol. So it is just like that. So in the next class we'll be discussing about this is distance vector routing, and we'll take one more class on link state vectors routing, and within this week we'll complete the entire module, and next week we'll start with the next module. So that's all for today's class. The next class we'll discuss all those things. I think there are only 30 students. This was the very less attendance. I never expected. Okay, anyhow, I'll take stock of attendance at the end. Okay, so I think tomorrow you are having one more test, or is it done? You're having one more test. Yes. Okay, right. So no problem. We will okay. We will end today's class. So entire class recording will be all class recording will be available on this website, and also the study material notes for all the modules, module 1, module 2, which you have to prepare for your this one internals, is available in this particular link. So certainly go through this modules, and uh, yeah, we will have further discussions in the next upcoming class. That's all for today's class. Thank you very much.